Good afternoon. So I am Amitava Dasgupta. I'm in University of Kansas Medical Center, and I am the first speaker, and the second speaker is Kelsey Woodward, and she's sitting over here. And so I'm going to talk about the biomarker of Alzheimer's disease, CSF and plasma. Now, when I prepared the talk, I did not know there will be a whole talk on plasma biomarkers, so I might skip some of the slides because it will be repetition. However, at the end of my talk, I have my email address, and at the end of Kelsey's talk, she also had her email address. So if you have any question, you can email us if you think about a question later. Okay, I have only research grant from Beckman. I'm going to present some of the Roche biomarker, but I don't have financial relation. And I get book royalty from Elsevier, John Wiley, and Springer. Okay, let's come to the talk. Alzheimer's disease is an age-related disease and is scary because I have seen in my own eyes how my father-in-law deteriorated. He had Alzheimer's, and last few years are very challenging because they don't remember anything. It was discovered in 1906 by a psychiatrist and neuropathologist, Dr. Alzheimer. There are 6.7 million people, 65 and older, living with Alzheimer. And interestingly, it is a very lethal disease. People die within 10 to 15 years. And it was the 6th most common cause of death. Of course, you know, number 1 is the heart attack. And after COVID, which killed 1 million people, it now is the 7th leading cause, and I'm pretty sure it will go back to 6th leading cause. So let's talk about the prevalence. It is an age-related neurodegeneration, so very low prevalence for people between 65 and 74. So I am 66, so I'm in the beginning of it. I don't have Alzheimer's yet. But sometimes when my wife is not happy with me, I ignore her. And I say that I have a memory lapse. So it could be pre-Alzheimer's. But it is a huge problem when you reach 75 to 84, 32%. My father-in-law has an onset of Alzheimer's around 82, 83, and he started deteriorating. He died in 91, and last 3 years are very challenging. So the pathophysiology of Alzheimer's is known for a long time. Initially, people thought that this is due to build-up of amyloid plaque. Now, amyloid are solid protein, but unfortunately, in Alzheimer's, they become insoluble and they form the plaque in your brain. And for a long time, that was thought as a cause of Alzheimer's. But then later, people figured out it's not really the amyloid plaque, which is the major cause of it. It's a tau protein, especially phosphorylated tau protein. And what they do is that they interfere with neuron-to-neuron signaling, and the process is called tangulation. So it's like somebody choked me, I cannot choke. When neurons are choked, they cannot communicate. And there is a genetic factor, but it is not well established. It is not a monogenic disorder. So only thing we know is that ApoE polymorphism may be a risk factor. ApoE star 4 allele gives a higher risk because lipoprotein is, what they do is that they remove the amyloid plaque. But if you have ApoE4, then they are not a good chaperone to remove the amyloid plaque, you know, like a bad driver. That's the reason my wife don't let me drive at night, because she thinks anybody who learned driving in India is horrible. And if the way she drives in India will never go anywhere. So APO2 is not a common allele, and when there is APO2, then what happens basically, that gives a protection. They are like Indian driver drive fast, go from point A to point B much faster than an American driver. Okay, but you're not going to drive in India anyway, and you shouldn't, because I can't drive there anymore. And then APO3 is the most common one. So how do you diagnose it? Well, the family member notice it, that there is some issues because they are cognitive decline. Now, the cognitive decline can occur with the old age, and it's just like simple things like remembering names. Sometimes I see somebody after a few years and start smiling, I don't remember their name. And then say, oh yeah, it's so nice to meet you. And it's like, that's great, how is life? You just have small talk and then try to look at their badge because her name is written, and then you just act smart. But anyway, but it's not that kind of forgetting the name or something, it's more serious. And at the time, the family member get concerned and they take them to a doctor, refer to a neurologist, and you have to find out if this is an age-related dementia or it's Alzheimer's. There are some treatment for age-related dementia, but they don't really work for Alzheimer's. Now, there is one new drug, and I'll just come later. So what you need to do is that you can do the MRI. And before the biomarker came to the market, the diagnosis is totally based on MRI and PET imaging. And we still do it because it's a gold standard. So basically, those Alzheimer biomarkers are surrogate marker confirming a diagnosis that this patient has Alzheimer. And this is the PET scan looks like. I'm not a neurologist, so I'm not going to interpret this, but you can see, I can see colors, and you can see how the color changes. And when you have the Alzheimer brain, the blueness goes down. And what it shows, couple of things. First, it shows some plaque formation, and there is some special PET scan which looks into the glucose metabolism. In the Alzheimer disease, the glucose metabolism goes down, and that's one of the reasons you see those malfunction. And this is very obvious. You can see that, it's a normal brain, and as you have the formation of amyloid plaque and tangled tau protein, it is mostly the phosphorylated tau protein, which are insoluble, that causes this problem. And you can see the difference between a normal neuron and a diseased neuron. So basically what happened is that the tau protein spread and interfered with the communication. Now, this is known for a long time, and one of the reasons the biomarker did not get a widespread popularity is most biomarkers developed in European countries are CSF biomarker. Now, I don't think you can convince a patient with some decline in cognitive function, oh, it will feel great, like a massage, let me take some bone marrow and take me like some CSF from you. So I don't think they get excited, okay? So that's one of the reasons there is no widespread marker. Then what happened is, later in 2015, 2016, they start developing plasma biomarker. Now, that is okay, just give me some blood. But the problem of plasma biomarker, the concentration are like 1,000 times less. So you need to have a very sensitive assay to go to that low level. And one example is troponin. For many years, it is a regular troponin, which is nanogram per ml. Now we have a high sensitivity troponin, which is nanogram per liter, and that makes a huge difference. But you can see the biomarkers are elevated about 10 to 15 years before you see the symptom. And this plaque formation takes place after 55, 56. So if I do my MRI, I'm pretty sure I will see some plaque formation. The whole idea is either there should be a good treatment for Alzheimer's, so that can be reversed, or before I get completely senile, crossover. So these are the only two options right now available. Okay. Now, amyloid tau neurodegeneration is a system which have been used for a long time and is still used. So amyloid plaque is amyloid beta protein. This stands for tau protein, and N represents biological marker of neurodegeneration. And in the next slide, this is a very busy slide. I'm not going to go in details through it, but what you need to see that in CSF, you have low A-beta 42. And the reason is when the amyloid plaques are formed, they are insoluble. So you have a very low clearance in CSF, and very few can cross the blood-brain barrier and come to the serum, the blood. Okay. Tau protein, on the other hand, is elevated because there is so much tau protein, the tangulation takes place. And the neurofilament light chain, where assays are available, these are for research use only in plasma. And I believe that Fuji Brio has the assay, and Roche is developing the assay. And that gives you neurodegeneration. But this is not a specific marker. But if the values are higher, it most likely indicate Alzheimer rather than indicating that it's a dementia. Now, plasma is controversial because the values are low. So plasma biomarkers are focusing on tau protein, which is elevated total tau and phosphorylated tau. And you can also see elevated NFL. Now, Roche and Fujibio both have AB42 biomarker in plasma. And it is like controversial whether it's useful or not, but if you take into account A-beta 42 along with p-tau, you can have the ratio, which is a better biomarker. Now, this is a little busy slide, but what you can see that A-beta 42, low level in CSF indicates that it's Alzheimer. A-beta 40, there is an assay by Fuji Brio, but is used less commonly because it's inconsistent. Some people say the value goes up and some people say the value goes down, which I don't know why. Flotilin, there is no immunoassay right now. It might be a future biomarker, so I'm not going to talk about it. Now, p-tau and t-tau. P-tau means total protein, and they have 66 phosphorylation sites. So out of the 366 phosphorylation sites, 3 sites are clinically important, which is position 181, 217, and 231. And then you have NFL, which are usually useful as a surrogate marker, and you have vicinin-like protein. There is very little literature into this. It's increased in CSF. Nobody knows about plasma, and we need definitely more publication. So NFL is specific for neuron. So what happens is, if there is a damage of the neuron, it's more like a chronic thing. It's not like a traumatic brain injury. NFL get elevated, and that shows the dysfunction of neuron, okay? And there is the assay. It's not FDA approved, and Roche also had an assay which is available for research use only, and hopefully what I heard when I was in the ASCC meeting, also in Chicago, month and a half, that they have in plasma A-beta 42, p-tau, total tau, and NFL, and hopefully they will get clearance. And as soon as those are available for research use only, we'll be able to look into this. And that will make it is like a paradigm shift in diagnosis of Alzheimer's disease because you have plasma biomarkers. And another possibility is that what hypothesis is, there is one drug which is approved which reverses the amyloid plaque. And you also can reverse the phosphorylated tau protein. So what is expected is that if it really works, you will have increased clearance of amyloid beta protein, so the concentration in plasma should go up. So you can monitor it both clinically and biochemically. So what is most important here, which is highlighted, A-beta 40-40 ratio is significantly lower in Alzheimer's, and this is better than AB42 concentration. Tau protein is a fairly big protein, and most post-translational modification is phosphorylation. And as I say, there are 3 different positions. Now, total tau can be measured too, but total tau is not that sensitive. But if you measure the p-tau, there are some controversies. Some literature says 181 and 217 are equivalent. Some literature says that 231 is slightly better. But the problem of plasma is the much, much lower concentration of this biomarker. So it's more of an analytical challenge. And second thing is in CSF, it's a very clear matrix, but plasma has proteins and other things which makes the measurement more difficult. This is a laundry slide because I'm just want to list you all the assays available. And out of this correctly, ELIXIR, which is a Roche assay for A-beta 42, t-tau, and p-tau 181, run on the covers are fully automated and FDA approved. And Kelsey is going to talk about her experience. She implemented the test in the clean lab when I was daydreaming in my office. So she has more expertise on that. And so this is basically a laundry list. There are more assays available in Europe, but none of them are FDA approved. So now we're going to talk about the clinical utility. And you can see this cat is very curious to find out. Okay, so here you are, cutoff, okay? Now, since they're using different antibody, you can expect there will be some differences. And if I want to develop a glucose assay, okay, I want to start Dasgupta's company, no problem, because I can buy it from National Bureau of Standard. So my glucose assay will be as good as a Roche, Beckman, or Abbott assay. But those reference standards are not available. So since a company makes those reference standards, there is a slight difference in numbers. And as you can see here, that AB42 cutoffs varies. But look at A-beta 42, A-beta 40 ratio, less than 10. It has a very good sensitivity and specificity. So basically, that is something which we should use. And you can see here the numbers. You can see, I don't have a laser pointer, but that's okay. You can see here that it doesn't work. Okay, A-beta 40, plasma concentration 3830 star, okay? And plasma, that's in CSF. Plasma is 237. See what is a huge difference, okay? So, and it is not statistically significant between Alzheimer and the control. A-beta 42, you can see plasma is 19.9, okay? Not significant, but look at the CSF, so much higher. So that's one of the reasons that clinical utility of plasma biomarkers, the A-beta 42, are not known, okay? And another thing is look in the plasma and CSF. CSF p-tau 229.5 in non-AD, AD 1095.5. There is like 4-fold increase. You can't miss it. It's also increased in plasma 7.7, 8 to 27.8, and is statistically significant. So basically, that's the reason p-tau 181, which is available from ADX and Janssen. I did not list Roche because I don't have the package insert yet. But I just want to show you that this plasma biomarker, that p-tau and p-tau 181 and 217, they are going to be really, really useful because you can see they are increasing significantly. But in plasma, you can see the values are so little, but still they are increased, so it's good. So what we saw for the A-beta 42, the difference is not significant, okay? You know, I mean, it's very similar, like my face and the face of your orangutan, very similar. But if you look at some, pretty faces, then you can distinguish, okay? So that's what the difference is. And this is a visual one you can see, that you can see what is happening is that in CSF, A-beta 42 is significantly going down, p-tau and t-tau are going up significantly. So that's your take-home message. And you can see that A-beta 42, control, and Alzheimer. In CSF, it becomes significant. In plasma, it doesn't become significant. And t-tau, you can see that how much is increased. And you can see that if you look into the number, you are seeing 56% reduction in main AD, but when you look in the t-tau, you see 6-fold increase and 2-fold increase. So these are more significant. And this is the same thing you can see, the different companies, as I said, the values are different. And here, I'm giving you the number. It's too much number to see. All I want you to look at it is that A-beta 42 values in normal, MCI, and Alzheimer. MCI is a mild cognitive impairment, and you can see that A-beta 42 is going down significantly during that process, but A-beta 181 is significantly increased. So you cannot miss it. And you see the other things with the Fuji Brio, the same scenario. So regardless of your parameter, because if you're in the, I know lots of my colleagues are using Fuji Brio because it is also totally automated and a very good assay. So you don't have to change your assay, because you get the meaningful information. And this is from the another studies, and you see the same picture. So summarizing, A-beta 42 go down in CSF. P-tau and T-tau both go up significantly. Now, this kid is surfing, and I don't know if they would like it, because we have 2 cats and they don't like water. So, but this must be a big challenge. Okay, here is the challenge. What cutoff should they go for? Cutoff for male, they use a Roche assay, is 834 picogram per ml. And if you remember from a previous slide, if you're using the Fuji Brio, your cutoff is 507, because there are assay variation. Total tau less than 238, p-tau less than 21.6. But what is most useful is p-tau by AB42 ratio, which is 0.023. And if you're using, and there are different people who have different ratios. So we use less than or equal to 0.023 as our thing, which we adapted from Mayo. If you're using a different investigator, it's like 0.020. But if you are using the Fuji Brio, it's totally different. So I just want to let you know that you have to set up your own cutoff. And correlation, this is the most important thing. There are plenty of studies in literature. There are at least, I found about 40 studies. And because, these are the gold standard, okay? So what they found out is that they use a CSF biomarker, A-beta 42 of 750, p-tau 80, t-tau 300, and they found very good correlation with the imaging studies. So therefore, they know this works. And here you see lots of numbers. All I want to emphasize is that these are all statistically significant. So with the PET positive and PET negative, you can see that the values of A-beta 42 in PET positive is significantly lower as you expect. It's almost 50% lower. And as you expect, t-tau, they are significantly elevated. Now, don't get confused, because these are picogram per ml. That's the reason you're seeing high numbers. So that is a take-home message. They do correlate with the gold standard. Issues with specimen handling, Kelsey is going to talk about it because she knows more about that than me. You have to be careful because A-beta 42 is very sticky. Now, the good thing is while you are doing CSF, A-beta 42 is very sticky and a serious problem. But if you do the plasma, what I heard from the Roche people, that won't be a problem. And as I say, the plasma tau biomarker, I'm just going to give you a very simple synopsis. We do not know if plasma A-beta 42 is going to be useful. We do not know. But we know the plasma P181, 217, and 231, they can distinguish AD from non-AD tau paths. And Fuji-Brio, and there is a European company which has plasma 1821, 217, and there is one company has 231. Quinimex, I don't know if I pronounced it rightly, and Roche is going to develop all three, which will be FDA approved in a year and a half. Again, this study shows that plasma marker, like the CSF biomarker, also correlate very well with the imaging studies, which are the gold standard. This is a continuation of the whole thing. So P181, which is Quintrex, was more strongly associated with both AB and tau PET. But there are other studies which shows that 231, which is a Fuji bioassay plasma, which is available for research use only. You can use it, but you can report the values because it's not FDA approved. So to conclude, CSF Alzheimer biomarker, AB42, less than 834 picogram per ml, AB40-40 ratio, p-tau. These are the good, useful biomarkers. So right now, it looks like if you're doing the CSF, then AB42 p-tau ratio is 218 ratio, 181 is the best. And the value should be less than 0.023. Roche doesn't have AB40, but Fuji-Brio have. AB42 to AB40 ratio less than 0.10 is also a very good biomarker. Plasma is supposed to be the new age, and as I say that there is one drug which is already approved in March by FDA, which reverses the plaque formation, and we have some patient enrolled, but we are looking for the plasma biomarker to make sure that we can follow them for researchers only. And there is another drug which is more exciting because for a long time people thought Alzheimer is because of amyloid plaque formation. But now they think it is not the major culprit, okay? So the major culprit is phosphorylated tau protein. And there is a new drug which targets the phosphorylated tau protein. It's a immunoglobulin. And that drug is in phase 3, so should be approved maybe in a year or two, and that should be more effective. So what it does is that these are immunoglobulins, so you have to infuse it every 2-3 months, but it looks very promising. This is what my presentation is, and thank you for putting up with me. This is my email address, so if you have any question or anything, just let me know. And the next speaker is Kelsey Woodward, and she developed those assays in our laboratory, and she's going to talk about the practical experience.
All right, thank you, Dr. Dasgupta. Hello, everybody. My name is Kelsey Woodward. I'm Medical Lab Scientist Supervisor for Chemistry and Special Chemistry at the University of Kansas Health System, where we have implemented an Alzheimer's disease evaluation panel on spinal fluid. I have no disclosures. First off, a little bit about KU. We are an academic medical center located throughout the Kansas City metro. The majority of our testing funnels through to our main campus hospital laboratory. That core lab is a very busy and automated lab. We have a variety of chemistry platforms. Pictured here are our Roche Cobas E801s. They are named after Kansas City's own dynamic duo, Travis Kelce and Patrick Mahomes. This pair does perform our Alzheimer's panel. Our panel is a 3-component test. The A-beta-42, total tau, and phosphorylated tau 181 are measured, and then we do a ratio of the p-tau to A-beta-42 calculation with a positive-negative interpretation that is reported. So the approved use for the assay is to generate that ratio value for adults 55 and older with cognitive impairment as part of an evaluation for Alzheimer's disease. We do recognize that the assays are newly FDA approved, and in general, Alzheimer's biomarker testing is still investigative. So we do report each discrete analyte to our providers. Our providers prefer to have those analytes values, but they do have an understanding that they cannot be interpreted individually. The assay, like Dr. Dasgupta talked about, has a strong negative predictive value for persons with cognitive impairment, whether or not it's due to Alzheimer's disease. So the providers do use that negative interpretation or ratio below the cutoff, correlate it to the PET scans. Our procedure on the Roche Cobas E801 does use a sandwich principle. The assays are quite quick at only 18 minutes and completely automated. Minimal tech time is involved as those samples can be directly loaded onto the racks for the analyzer, as we want to perform that testing on that tube that the collection occurred. Our validation was straightforward. Our precision between runs and between analyzers were all acceptable. Our correlation was unique, as those samples are unique and precious, being spinal fluid. We did use characterized samples from another Cobas system and had excellent results. We appreciated the sample sharing for this newly developed test, and we have returned the favor by partnering with other labs in need of correlation samples. I will admit we had it easy for implementation. We had transitioned this test from a send-out to performing it in-house. Our teams, our providers, were already well-versed with the collection requirements, and as you might know, sample handling education can be a heavy lift. That education is an important aspect, like you've heard Dr. Dasgupta talk about. For this testing, there are very specific requirements. The collection must be a drip method, not using a syringe. You may not use the first 2 mils for testing, and you cannot use those polystyrene tubes. Instead, you have to use the specific low-bind tubes to prevent those proteins from sticking to the tubes. Here is a snapshot of our testing so far. Since we went live earlier this year, our testing volume has increased. We are monitoring as we go the volume, the ordering trends, and our percentage above cutoff to kind of understand the clinical utilization as we continue this testing. There are other spinal fluid biomarkers on the market, such as the Fuji ReBio, with 2 other A-beta and 2 other p-tau assays, although they are not FDA approved. Lastly, plasma biomarkers. They are of great interest, as everyone's talking about. We know the testing landscape is definitely still evolving. Our providers are definitely looking forward to evaluating and implementing the plasma assays and kind of fold them into our testing in the coming years or when those FDA approvals do happen. That is all about the implementation. Dr. Dasgupta will come up if we have any questions. Thank you.
Okay. And if you think about a question when you walk out or when you have dinner, you can always email us. So, yes, that's my email. Just email me, and I can send you the slides, and I can put you with the other expert, like the clinician, like Dr. Burns and Dr. Morris, and they can answer more questions. You know, this is my more recent interest. I'm a toxicologist. But what drives me this is my father-in-law. He has Alzheimer, he died, and it's so pathetic. So when I moved to Kansas City, when I got introduced to this group, so last 2.5 years, that's my new obsession.